Hello everyone, welcome to the video. So here we're going to talk about the new rumoured Canon release that's due to be announced in 2 days. And what lens are we talking about? We're talking about the Canon 200 to 800 f6.3 to f9. Basically it's probably going to be white paint, unconfirmed. It's a non-L lens and not weather sealed. Possibly an STM autofocus motor. Prices range from $2,000 to about $2,200, and it'll be about about £2,500, because us in Europe always pay more. It's going to be diffractive optics element like the 800mm f11, 600mm f11. Very similar to the DO elements that's actually in the f4 400mm DO lens. So obviously it's not going to be an L lens, because it'll be a diffractive optic elements in the actual lens, and likely to be externally zoomed, so it won't be internally zoomed like the Sony 200 to 600 6.3 lens. And it obviously will be stabilised as well. Now the aperture starts out at 6.3 to f9, which is quite a dark aperture, as you may appreciate. So essentially that's the breakdown of the lens. My thoughts on someone who tests telephoto lenses out, such as the Sigma Contemporary Sport, 150 to 600, the RF800, RF600, and other lenses as such, including the Tamron 150 to 600, both the G1 and G2 as well, not forgetting those two. When I tested the 150 to 600 Sigma lens Contemporary versus the f11 RF lens that Canon make, I found it was a little bit softer than the Sigma lens. Obviously the Sigma lens is not diffractive optics, and obviously the 600 f11 is. So I wanted to briefly talk about diffractive optics. What is it? And I got the information directly off Canon's own website. So Canon obviously have pioneered both aspherical and fluorite lens elements. Canon went on to develop a technology that combines the characteristics of both multi-layer diffractive optical elements. Technology was announced in September 2000, and a prototype lens was shown at the Fokina 2000 exhibition in Cologne. Canon EF series lenses that incorporate DO technology have a DO in their names, like the EF 70-300, f4.5 to 5.6 DO IS USM. Although Canon series lenses like the RF800mm f11 IS STM no longer follow this convention, bringing them in line with all other RF lenses which do not include lens materials in their names. But it doesn't necessarily mean it doesn't include diffractive optics, obviously, in the actual lens itself. Diffractive optical elements use a diffraction grating that alters the path of the light rays. So basically what they're doing with the lens is they're getting one of the pieces of glass elements actually in the lens, and they're slicing it in half, and then they're literally grating the various parts of that element and separating it into two. Now later on they developed technology where they didn't have a gap, because I don't know if any of you guys are actually familiar with the DO 400mm Mark 1 lens, and a lot of the elements were near at the front, and there was a lot of complaint that a lot of flaring and ghosting was happening in that lens. So then in the Mark 2 version that brought out, retailing incidentally for £6,800, a lot of money, they moved those elements further back to reduce the flaring that was going on. But when you slice an element, you introduce all so many possibilities of light deviating from its normal trajectory into other trajectories, and it complicates things a lot. So diffractive optical elements use diffraction grating that alters the path of light. So instead of the light going like that through your lens, it alters it, so it might bend a little bit. And then you have like a counter grafting on the other side of the element, because they've cut it in half, and on that side it alters the trajectory and focuses the light in a tighter beam, and this is why the lens can be a lot smaller. So as we talked about, it alters the path of the light. Rays diffraction is encountered in ordinary lenses. When a small aperture is used, light rays passing through this aperture are bent very slightly, so they are no longer travelling in a straight line. This affects the focusing and reduces the resolution of the lens. The diffraction is the reason most lenses give their best performance at an aperture above 2 stops below maximum, rather than at the smallest apertures. However, a diffraction grating can be used to introduce corrections rather than create aberrations. So in DO lenses you tend to have a reduced amount of chromatic aberrations, which tends to be like a green tinge or a purplish tinge, depending on the subject matter you're taking a picture of, and it reduces that hugely. It may even eliminate it in some cases. So diffraction grating looks a bit like miniature versions of the Fresnel lenses used in a lighthouse. They are widely used in spectroscopes and in the optical signal reading systems of CD and DVD players. Until 2000, diffractive elements had not been used in camera lenses because there is a tendency for white light to produce superfluous diffracted light as it passes through the grating. This results in flare, which degrades the image quality. Canon resolved this problem by creating a multi-layer construction made from 2 single-layered diffractive optical elements with opposing centric circular diffraction gratings. When incident light enters the element, superfluous diffracted light is not produced, and almost all of the light is used for the image. This makes it possible to use a diffraction optical element in a camera lens. So basically you're focusing all the light onto the sensor within a set field, rather than in a typical lens you might be wasting some of that light and some of the obviously lines of light that's going through the lens. The most significant characteristic of the diffractive optical element is that the positions where the wavelength combine to form an image are reversed from those of refractive optical elements. By combining a multi-layered diffractive optical element and refractive optical element within the same optical system, chromatic aberration can be corrected even more effectively than with a fluorite element. Also, by adjusting the pitch spacing of the diffraction grating, the diffraction optical element makes possible the same optical characteristics as a ground and polished spherical surface, which effectively corrects for spherical and other aberrations. Using a DO element also enables a lens to be made much more compact than it would be with a standard telephoto design. The EF400 f4 DO Mark II ISUSM, for example, is about 26% shorter and 36% lighter than an equivalent non-DO 400mm f4 lens. So basically, by using these DO elements, you're able to shorten the length of the lens and make it lighter. However, It is always possible that there may be a reduction in sharpness because you are reducing the glass elements by a little bit. That's why you're making the lens lighter, but you're also removing some of the glass. That's something to keep in mind, because when I've done my tests, such as the Sigma Contemporary lens, it just seemed a tad bit sharper than the 600 DO lens was. I don't know if that's because it was a pure element versus a diffractive element. It's up to debate, this is, which is the better. You know, I think pure glass is better than having a glass that's been spliced and then grated out, as they said in this document. So moving on, because basically the issue with the DO Mark 1 lens, 400mm f4, is they left a bit of air gap in between the grating of the same element where they cut it in half, and it was creating stray light and flaring. So in September 2014, Canon announced an EF 400mm f4 DO Mark II IS USM. This compact super telephoto lens debuted a new generation diffractive optical elements that reduces the flare that can sometimes occur in earlier DO lenses. The original dual-layered DO design sandwiches a layer of air between the two diffraction gratings. This air and the material that makes up the gratings can cause some ring-shaped flaring around bright light sources in the image. Switching to a gapless design plus the use of a new material for the gratings reduces the occurrence of the flare. The gapless dual-layered DO is also positioned deeper into the lens and further from the front element in the EF 400 f4 DO Mark II IS USM than in the EF 400mm f4 DO USM. This means that it is less exposed to unwanted light, which can cause flare. Another impact of the change is that the angle of light reaching the lens is closer to the perpendicular, so less light is reflected, and the likelihood of flare with backlit subject is reduced even further. So in RF lenses, as mentioned, using a multi-layer diffractive optical element enables a lens to be made considerably smaller than a traditional lens construction. This is especially beneficial with super telephoto lenses like the RF600mm f11 IS STM and the RF800 f11 IS STM, which are designed for use on full frame mirrorless EOS R camera systems. The RF600 f11 IS STM is constructed with 10 elements in 7 groups, while the RF800 f11 IS STM has 11 elements in 8 groups, and both include a multi-layer diffractive optical element. At 269.5mm in length, when it's extended, ready to use, the RF600mm f11 IS STM is almost 40% shorter than that EF 600mm f4 IS Mark III USM. Similarly, the RF 800mm f11 IS STM is also almost 24% shorter than the EF 800mm 5.6 IS USM. This reduction in their working length makes the lens easier to use and handhold, and they feel more balanced on a camera, especially when you're shooting without an optional battery grip. Both RF lenses also feature a collapsible design, meaning they are compact to 199.5mm and 281.8mm in length respectively, making them easy to transport and store. With a bladeless aperture fixed at f11, the lenses also capture attractively smooth bokeh, while the image stabilization helps to deliver sharp images. Using a fixed aperture reduces the number of variables that need to be considered in the design of the lenses. This makes it possible to optimize the optical construction to make the best of use of the DO element and maximize image quality. So why am I reading this out to you, you might be asking. This is directly from Canon Global. I wanted to give you an idea of what the DO lens construction is all about. Basically, it allows Canon to reduce the size of the lens by splicing one of the elements in half and grating it in such a way, using some sort of laser cutter, to reduce the size of the element and obviously move it further in and closer together. And instead of having light rays literally going in a straight line like that to the sensor, what happens in the actual DO lens, it has a habit of bending the light towards the sensor. And this is like focusing, pushing the light in a certain direction towards your sensor. That allows the manufacturer to cut weight down and make the lens smaller. So going back to the new release of the Canon lens that we've been discussing, obviously the 200 to 800 f6.3 to f9, it's going to have a diffractive optical element in there. Is it going to be quite as sharp as a full L lens? No, it isn't, and it's going to be considerably lighter. And obviously, it's going to be it's not going to be weather sealed. The reason for them to put paint on is to make the lens more resistant to hot temperatures. You know, if you're the type of person that goes to Africa a lot, you will appreciate that, because you know, it's like if you get a white hat, it refracts the heat more than wearing a black hat would. So that's essentially the reason why they probably want to paint that lens white. Using an STM motor is likely to be a lot cheaper than installing nano USM motors, which obviously bumps the price up on the lens construction. And obviously I'm talking about the DO element. You know, please keep watching in this video, because I'm going to put up a video from Canon showcasing how a DO lens is constructed. So it's likely not to be an L lens, and it's likely to be an externally zooming lens with image stabilization. It's going to be a really nice walk around lens. Unfortunately, I just feel that the aperture of 6.3 is starting out at 200 millimeters, and then we don't know how that transitions. Will it be f8 at 600 millimeters, or will it just get to f9 at 500 millimeters? We don't know. So obviously, before the lens is officially released, I thought I'd do a video just talking you through the actual specifications of this lens. If I was to estimate obviously a pricing on there, we're probably talking between $2,000 and $2,200 and £2,500 or €2,500. And I think that's the pricing where we're going to see this lens priced at. Do I think that's overpriced for a lens that is not an L lens, for a lens that has no weather sealing, for a lens that isn't using a nano USM focusing motor? I think the pricing of this lens should be something ranging between £1,300 and £1,500 in my personal opinion, because if you look at the pricing of the 180 to 600 Nikon lens, or the Sony variant, the 200 to 600 6.3, you can get those lenses relatively inexpensive. They're not that expensive. I think that Nikon is around the £1,800 mark, and I think that the Sony one can be had for around £1,500. I would have preferred to have seen a Canon new lens coming out that was something like a 200 5.6, possibly going to f6.3 at 600 millimeters. I would have liked to have seen that, but unfortunately that never has come to pass. And for those guys of you that have followed my channel, big thank you for coming. I did an announcement video many years ago about an EF patent that was done in Japan for a 5.6 200 to 600 6.3 lens. It was never made, but they did actually go for patent. Just remember that, guys, that a lot of lenses that Canon applies for patents for these lenses, but actually never produced the lens. So without further ado, I will give you the video from Canon regarding what a diffractive optical element is. I hope you found this video was helpful, and I'll see you in the next one. And remember, before you go, please remember to subscribe to the YouTube channel, like the video and share it with anyone you feel may enjoy content like this. I do apologise if I've gone on a little bit reading the documentation here, but it is quite important for people to understand what the diffractive optics actually is, and what Canon says about it. And I hope I've explained it clearly for you. Thank you for watching, and have a nice day.